In this lecture, we're going to take an examination of an example in which the two-way chi-square statistical procedure would be applicable. And this is an approach that we would use in the event that we actually have two independent variables. And we're taking the same approach in that we're just simply counting the frequencies, which is the number of occurrences that fit within the two independent categories. And we continue to make the same assumptions when applying this non-parametric test. And the two-way chi-square is often referred to as the test of independence, and we'll see that shortly. In this example, we're going to pose the research question of whether there is a relationship between personality type and cardiovascular disease. And this is going to be what's called a 2-by-2 design, in which there are two independent variables, but there are two levels or two categories within each of the two independent variables. The first independent variable is personality type. So from a research perspective, we're developing a set of criteria, one of which is that individuals will be categorized as either a type A or a type B personality. The second category relates to whether the individual has markers or possesses markers of cardiovascular disease. And so they either have the disease or they do not have markers of cardiovascular disease. And so in the table here, we see that the two independent variables are indicated in personality type with the two levels, type A and B. And we have the other category, the other independent variable with two categories, cardiovascular disease and no cardiovascular disease, or no cardiovascular disease. And we have a number of observations within each of these cells. And so what we're going to do here in this approach is we're essentially evaluating how the two independent variables of personality type and disease presence interact. And so what the overall approach is attempting to address is whether having cardiovascular disease is or depends on personality type. And to illustrate how the two-way chi-square would be used to examine this question, we look at two rather extreme examples here. In the first example, what we see here, if we had a situation where we have 20 observations, 20 individuals of type A with cardiovascular disease, and 20 individuals that fit the type A personality with no cardiovascular disease, and likewise with type B, we have an equal number of individuals identified with cardiovascular disease and without cardiovascular disease. This is termed a perfectly independent relationship, and it's perfectly independent that there is no observation, there is no obvious pattern of whether individuals of a particular personality type have the presence of cardiovascular disease. On the far other end of the spectrum, we see that 40 individuals that were randomly selected from a pool of the type A were of the type A personality type. All 40 had cardiovascular disease, and 0 did not have cardiovascular disease, which is the opposite for those in the type B personality type, in which 40 did not have cardiovascular disease and none were identified as having cardiovascular disease. And this is a perfectly dependent relationship. So going back to the first example of a perfectly independent relationship, we clearly see that there is no pattern here. And so possessing or being categorized of a particular personality type did not influence whether the person had cardiovascular disease or not. The individuals randomly selected in this situation had an equal chance of testing positive for cardiovascular disease or not. On the opposite pattern, or in the second example, we see a very clear pattern that has emerged where the personality type was perfectly correlated to the presence of cardiovascular disease. But in a realistic research situation, we might have something a little bit more closer to these sample data right here, where we have 25 observations of the type A and cardiovascular disease. We don't have 0, but we still have a much smaller number than the 25 here for that have cardiovascular disease, that do not have it, and we see a similar pattern emerge for the type B, where the majority of those individuals classified as type B do not have cardiovascular disease. So although we won't go through the calculation approach, we will examine the hypothesis statement in this type of scenario. So we always start with the null hypothesis, and in this example, the null hypothesis states that category membership on one variable, the first variable is personality type, so membership of a category means a person has been categorized as type A personality or type B personality, is independent of category membership of the other independent variable. And that was what we observed on the previous slide in the first example. And so in this case, what we're essentially stating with the null hypothesis is that one variable is not correlated to the other variable. The alternative hypothesis here will state that category membership on the two variables is dependent, which is to say that a person who is typed as type A is likely to possess cardiovascular disease systematically rather than due to random chance. And so what we see here with a two-way chi-square, although we won't be covering the mathematical approach in answering this question, it would be somewhat similar to the one-way chi-square, but the important element of a two-way chi-square is that we're able to examine two independent variables simultaneously by examining how those two independent variables interact with each other. And just by making a subjective observation of these data, we would suspect quite strongly that there is a dependence on personality type and cardiovascular disease, given the pattern of these numbers, which is more similar to the second example on the previous slide. So this ends our lecture on the two-way chi-square.